What's going on, guys? So today we're getting into our Unit 3. It's all about functions and sequences. For this semester, we're just going to focus on functions, and then we'll get into sequences later on. So for now, let's introduce these functions. Two learning objectives for today. I can determine if a relation is or is not a function, and I can find the domain and range of these functions. Let's start off with some vocab. First off, domain and range, when we're talking about that, we're talking about all the first values of the relation when we talk about domain. All of the x values of that relation or function, that's our domain. So the opposite would be the range, which would be all of our second values, all of our y values. Here's an example. Let's say you had these things listed, all the first things in your table, domain. All the second things in your table, range. A function is a relation in which each element of the domain is paired with exactly one element of the range. Another way of saying it is that there is one and only one output with every input. You can't have the same x value going to two or more different y values. The way I like to think of functions, guys, is like a machine. You put something into that machine, you should only get one something out. Here's what function notation looks like. It's very similar to our equations we've been dealing with before, but instead of saying y equals, we're now going to say f of x equals. And all that means is we have our output y, we have the name of our function, f of x, and x is our input. One thing I want to emphasize, a little thing that's kind of tricky with functions, we see the parentheses like this, we're thinking multiplication, right? With functions, not multiplication. This is just the name of our function. We can name that anything, any variable we want, as long as you're not putting a number out there. But we could have p, m, we could have z, x, y. We could have pretty much any variable out there we want. But function starts with f, so most of the time you're going to see it as f, maybe a g, maybe an h. It's called f of x. Let's look at some examples here. Determine whether each relation is a function. So here's a relation, and all it is just a grouping of ordered pairs. We're going to put them through the function machine and see if each input only has one output. So here's the first one. We have 2, 3. So that x goes into the function, spits out the output, which is 3. Then we have 3 goes in, comes out as a 0 because it's 3, 0. 5 goes in, comes out as a 2, 5, 2. And then 4 goes in, comes out as a 3, 4, 3. Looking at all of our inputs, 2, 3, 5, 4, they're all different. Because of that, this is a function. I want to slow things down just for a quick second, guys. Don't get confused. Don't worry so much about the machine. When we're talking function or not, look at those x values. Look at those inputs. Are those all different? If they're different, it's a function. If they're not different, not a function. Take a look at another example. 4, 1, 5, 2, 5, 3, 6, 6, 1, 9. For those of us that are starting to understand it a little bit, you might be able to tell right away if this is a function or not. But I'm going to put it through the machines again. So I have 4, 1, 5, 2, 5, 3, 6, 6, and 1, 9. Looking at all of our x values, all our inputs, are they all different? No. 2 5s go into 2 different outputs. Because of that, not a function. You cannot have repeating x values with different y values. You could also find out if it's a function or not by looking at graphs of your relations. And if you have two x values, if you have two y values for the same x, then it's not a function. So there's something nice about the graphs though. It's called the vertical line test or the pencil test. And basically, what you're going to do is take a vertical line and move it through your graph. If it hits more than one point of the graph, then it's not a function. Take a look at some of these examples. Take a look at this one here. Here's a straight line going through. Imagine we had a vertical line going through and hitting every single point. Do our vertical lines hit the red line, the graph line, just once every single time? The answer is yes. Here's only one time. One time, one time, one time, one time, one time. Since it's only once every vertical line, that's a function. Take a look at this one. Little U-shaped graph. Put that through our vertical test. It's one time here, one time, one time, one time. Looks like it's one time all the way through, so function. What about this one? Vertical line test. Okay, we're once here, but boom. Once, twice. Once, twice, once, twice, once, twice. Since it's hitting more than once, not a function. Try a few more of these. Is this graph a function? Yes, it is. Is this graph a function? Clearly not. It's a straight vertical line. How about this one? Not a function. This last one? Function. Okay, so I want to go to Delta Math really quick, guys, and I want to show you just a couple of each of the problems that we're working on. Now, for the stuff we've been doing, you've probably noticed you have a lot of relations, a lot of ordered pairs that we're trying to determine if it's a function or not. Think about that function machine we just discussed, or more simply, just look for all the x values. If you have any repeating x, not a function. So this first one, I have -2, 0, 8, and 7. They're all different. Moving on. -3, -5, 7, 2. Those are all different. Moving on. 2, -5, -6, -5. Boom. -5 repeat. -5 repeat. That one right there. Not a function. Your second one, determining if a graph is a function or not. Well, we just went over our vertical line test. Now, these are going to be a little trickier than what you saw on the PowerPoint, but it's the same kind of idea. We're taking a vertical line test and we're just moving our way through. And even though this is getting super steep, believe it or not, it's actually not touching. It's not going to stay, it's not going to go vertical. So we could say function. And I like the delta math at the end of this thing because it takes the vertical line and moves it straight through. There it goes. Let's try another one. This one's a little easier to see. Nothing going on over here. A lot of stuff going on over here. Think about your vertical line test. There's once, twice, boom, not a function. Watch it hit right there. And actually, it'll hit twice pretty much this whole time. Twice, twice, twice. One last thing, guys, dealing with that function notation. Remember, the inside parentheses is our input, and the output is the y value. So I have f of -2. So I'm looking at my graph for x, -2. And then I go up to that point. Okay, there's my point. It's a, and it's at 2. So I want to put a, -2. And that's what we're going to do for the rest of this function notation. Take a look at this other one. We want f of x equals 4. Okay, this is my y value because it's the output. It's what it equals. So I'm looking f of x equals 4. So I go to the y. I go to 4, and I look for the point. Boom. Turns out it's a again. What's that a value? The x is a 1. Basically, you're trying to pair these guys up. If they give you the x, find the y. If they give you the y, find the x. Let me do one more just to make sure we're okay with it. We're looking input here. Input was our domain. Input was our y. Input was our x's. So we're looking x, 3. And then from there, I'm looking up or down for my point. Boom, there it is. It's c. With that said, what's the y value? What's the output? We have the x. What's the y? This time the y, -5. They give you the x, you find the y. They give you the y, you got to find the x. This time they gave us the y. So let's go y of 2. Let's find the x. Well, we're right on that line, so this turns out to be a rare case. That turns out to be a 0. Hit me up with any questions, guys. But I think we're going to be just fine with this one. Talk to you guys later.